Okay, buckle your seatbelts. Here we go. All right, so we're going to start with this differential equation. All right, and we're going to work through solving this differential equation, and we'll see that in the end we end up with the logistic equation that we talked about on the previous page. Okay, so the first step is we have a separable differential equation here. So just like for any separable differential equation, we're going to separate the variables. And when we do that, it looks like this. So I divide this whole term over, I multiply the dt over. Now I want to integrate both sides, just like I always do at this phase of solving a separable differential equation. This side is really simple to integrate, but this side is not so much. If you think about multiplying this y through here, I have a denominator that's quadratic in y and just the dy in the numerator. And that's not, there's no pattern that we're familiar with that is going to help us solve that. So we're going to use partial fractions to separate, to split this up into things that are easier to integrate, to expressions that are easier to integrate. Okay, so I'm going to kind of take an aside here. We're just going to work on this part. We're just going to work on the left part of this equation for the time being. And so I want to take that 1 over y times the quantity 1 minus y over L, and I want to split it up so that I have a sum of two fractions, one of which has a denominator of just y and one of which has a denominator of 1 minus y over L. Alright, so I designate those numerators as a and b, as we talked about in one of the previous videos about partial fractions. I'm going to multiply through by the LCD, which is y times the quantity 1 plus y minus y over L. So I have 1 equals a, the y's cancel out and I just have this quantity in the parentheses, with b, that the whole denominator cancels out and I just have y. So now I choose values of y. If I let y equal L, then I get 1 minus L over L, so that's 0. So I get 1 equals B times L. And I can solve for B and I get 1 over L. So there is my numerator there. If I let y equals 0, I can clearly see that this whole term is going to turn into 0, so I get 1 equals a times 1 minus 0, so a is 1. So that gives me that numerator. Okay, so if I return to that differential equation, well, I'm not going to return to the differential equation yet. Well, let's simplify this a little bit more. So I have split up this original denominator into y and 1 minus y over L. I have my a and b here, and I have a complex fraction here, so I'm going to multiply through, I'm going to multiply this expression through by L over L. And it comes out nicely to just 1 over L minus y. All right. So I've successfully taken my original expression on the left, and I have decomposed it or split it up into that sum. And now I can go back to the differential equation. So initially this was my integrand. Now my integrand is 1 over y and 1 over L minus y. So those are both very easy to integrate. I have natural log the absolute value of y minus natural log of absolute value of L minus y. And of course, as we discussed earlier, this right side is really easy to integrate. It's just kt, and I have that constant of integration there. All right. I can combine up these sides, or I'm sorry, I can combine up the left side into one natural log. And then I can flip this over. All right, so think about what happened there. I really multiplied, I could have done it up here as well. If I multiplied both sides through by a -1, then that would change the order of these two terms, and then I would get L minus y over y. Here I just get negative kt now minus a c sub 1. So the question is, why would I do that? And the answer is, if I have a two-term numerator and a one-term denominator, it makes it much easier for me to split that up. Right? Think about what I'm trying to do here. I'm trying to solve for y, and I have to exponentiate both sides. But if I try to exponentiate this one, I have a really complicated expression. But if I do this, then I can exponentiate both sides, and I'm just left with L over y minus y over y, which is just L over y minus 1. All right, I'm going to exponentiate the right side. I get e raised to the negative kt minus c sub 1. And now when I solve for y, I'm going to add 1, multiply y over, and then divide by this entire left side here. That gives me my denominator. If you compare this with the previous page, you'll see that this is a logistic equation that we discussed on the prior page. All right. There's a lot to that. Again, as I said, you are not going to be expected to work through that entire derivation on your own, but it's a very good idea for you to watch that a few times, really think about what's happening there. This is a great practice for a more difficult separable differential equation. So if you can master this one, then most of the other separable differential equations that you encounter are gonna seem pretty straightforward. And there has been a movement recently toward having separable differential equations that look very much like the logistic equation, differential equation on the exam, but that vary just a little bit, and we actually do have to go through and solve that differential equation. So again, it's not something in this specific case that you'll be required to do in detail, but it's great practice, and it's definitely something that would help you a lot if you could understand the steps involved in doing that.